For anyone new here, I'm a software developer professionally, and started doing this course as a way to hopefully show some people some things about the web, maybe give you some tools to write web code, maybe like make your own website, but also just like help you understand the web is the major goal. It's just like understand, you know, what are some caveats, or like what are some of the pieces of technology that like make the web work. So and yeah, this week I want to get into some kind of special CSS concepts, that is cascading style sheets. It's part of the technology stack that makes up the web. So I will, let me share my screen. We will do this screen, do that. And yeah, we can get started. Just a couple of notes to go over, like kind of bookkeeping stuff. This is like the home base for our project. This is using GitHub. It's a place where we host all of our projects files. So anything that like I'm working on that looks like something like I've made or modified that I'm talking about, it's hosted here. It's publicly accessible. It's just easily reached this URL here. So the main things I wanted to highlight, and I'll continue to kind of like reiterate this as we like move through the course. A lot of the core technologies we're always going to talk about with the web are going to be HTML, CSS, and JavaScript. Those are predominantly considered like the basis of like any web page, excluding like backend or something like that. But backend, i.e. like code that isn't running on my computer, but I might send a request to it from my computer, like from my browser, to perform an action or something. That code like isn't mandated by like web standards. Like I could write that code kind of with anything I wanted, as long as I use JavaScript to make that request. So those three, the HTML, CSS, and JavaScript, those are like a core part of the framework, because there's standards that allow people like, you know, Mozilla, Microsoft, and you know, other large sort of bodies that help build technology to let us use the web, like browsers. These are core frameworks because we all agree that they work well, and we can make standards around them so that we can have like communication across all kinds of different platforms, like cell phones and laptops, and even like smaller like embedded devices or whatever. Like we all agree on these technologies because it makes it easier for everyone to use like the web. So that's just a little bit of, again, just like a kind of a reiteration of some of these core principles. But to kind of summarize those technologies, so HTML is what we use to describe and organize content. So if I go to one of my sample pages here, which the kind of like final product of all of this code that's hosted here is on this page. So if I go to one of my sample pages here, this resources page, where I've collected some very generic resources for everyone to check out. If I go to the HTML, this file, which is hosted here, it's called helpful links. So this HTML here is what I'm talking about. And this is what we use to describe the organization and the content of a web page. Likewise, the CSS, which I've included in this code here as a little like a group, like a special sort of piece of this file, you'll see that this code looks different from this code, and that's because it's a different language. It's CSS, and which we talked about a little bit more in depth previously. This is what we use to kind of like on a web page, identify or clarify content that we've created on our page with HTML, and to separate and kind of decorate content is the way I like to say it. So the coloring you see, the kind of spacing between each of these lines, the indent here, the you know, the kind of bold text, like the way how bold it looks, all of that is CSS. And then JavaScript is kind of like the kind of like flow between all of those things if you were talking about doing something dynamically. This page has no JavaScript on it. Nothing is happening dynamically. I could reload this page 300 times and I'll get the same content every single time. So there's nothing dynamic about this content. So if we wanted to introduce change or any dynamics, manipulation of the content that we've provided with our HTML, we would use JavaScript. So that's just kind of a reiteration, an extended reiteration of some of the core concepts. And we're going to be specifically talking about CSS today. So how can you quickly observe some CSS if you're looking at like a generic page, like this page, for example? Well, I can use the inspector tool. This is available to you in any browser, like I think I've mentioned before. But usually for any of these tools, you're going to get some tabs. Today, we're going to be looking at the style editor tab. Not specifically isolated here. The style editor tab will basically show you any style sheets that have been rendered. And when I say style sheets, it means like any CSS code that is being used on the page. This is what this style editor will let you view. You'll notice here that it says inline style sheet 1, and that's because of what I talked about here, where I said that I included my CSS as like a special group within my HTML file. If I included it as a separate file, a .css file, similarly as I would have this .html file, in this .html file, if I wanted to have it as a separate CSS, I would have a separate little group here that would just say like style sheet. Let me find a good example of that though. I think I have one maybe. I typically do inline if it's very minor styles. So not a great example I have on this page, but we might be able to really quickly see using our handy Mdn Web Documents, which is just a really, really fantastic documentation like collection for any web technology. But if we look through here, maybe some of these first steps, and if we take a look, I bet you there's going to be an example here of a style sheet. Yeah, okay, here we go. So we do this link like this, and then it's saying just styles.css is like the name of our file. So in our example, we would do, I went to my page back here. So this is our page that we're looking at the code for. I could basically grab all of this content and just cut it out. And then I could put this in a separate file called like style.css. I would put it in the same folder as this HTML file, and I could refer to it the same way they do here. So that's just a quick aside, but I think it's important to know that all of these files can be separated logically. So going back out of why this says inline, it wouldn't say inline if I had provided a separate file. It would say styles.css or whatever you named your file. We can see all of the included rules. These are called rules. that we set up with our CSS. So I'm going to be flipping between this, and I'm going to be flipping between the inspector. The inspector is a tool for basically looking at the DOM, which we talked about last time, in terms of like the rendered representation, meaning like we built our DOM out using our HTML code, and now we are looking at it as the browser decided to like build it into a page. And this inspector lets us kind of browse all of those elements.
Like looking under the hood, you can check out the components, you know.
Yeah.
Things are kind of working.
Yeah, absolutely. That's a great way to put it. Yeah, we're just like we're doing kind of like a deep dive of like what exactly is our web page made out of. But you'll see over on the right, which is what I want to focus today, this series of rules, which look similar to these. And the reason they look similar is because they're the same rules. But what this breakdown is showing us is basically element by element, where these are HTML elements here, these individual selections. It's showing us element by element which rules are applied. And these rules come from this particular sheet. So you'll see body, there's a body rule, there's LI, which is a list item rule, and there's this LI with a class specified rule here, which we talked about last time, how to break down this attribution, but I'm happy to stop and kind of pause if we want any clarification there. But basically what I want to get into today is understanding, if you look as I'm moving through these elements and sort of highlighting, you'll see that I'm getting this nice like selection, like a shaded selection of like what exactly I'm highlighting. And you'll notice it takes on like a box form. It gives us some, I can't like leave it selected. That would be kind of cool if I could. Maybe I can. I'm not sure that we can. Oh, here are some DOM properties though. That's pretty cool. So we can take a look down here actually. For the people that were joined last time, and for anyone hopefully watching after seeing the DOM video, you can see a really nice breakdown of like all that goes into building a DOM, which is our document object model, the big giant representation of like everything that goes into our web page. So this is a really cool, I didn't actually know about this ability to like break it down like this, but this is pretty useful if you wanted to like learn a bit more. It's got all of our information here to basically build our web page, so that's cool. So what I wanted to talk about is like.
Can I ask a question?
Yeah, sure. Mm-hmm.
Sorry, I don't want to break it up. You were talking about languages. You were talking about HTML, CSS, and JavaScript. I just wanted to know what is Ruby's relationship to those three, the way that you describe the relationship between them. How does Ruby connect to that?
Oh yeah, that's a good question. Yeah, Ruby is like a kind of a more like it's, what would I call it? Like it's like not an anchored language. So I haven't used much of Ruby personally, but I've used a language like Python, which is also like a scripted interpreted language. Ruby doesn't have a dedicated technology stack is the best way I would say it, or as in like it doesn't belong to any particular technology. So you can write Ruby code that doesn't have to live in the web. I mean, similarly, you can write HTML, you can make HTML documents that aren't used by web browsers, but a web browser will acknowledge it. There's nothing in the web browser for like Ruby, for example, to my understanding, unless you are including like additional modules that would allow like the browser natively to understand what's going on with like Ruby. So what you need is like a lot of like, you need other technology assets to kind of bridge the gap between like Ruby and like JavaScript. So a lot of stuff, I think it's like called Ruby on Rails, but you'll have to forgive me. I'm not as familiar with Ruby other than just like generally what it is, but I think Ruby on Rails is like the web kind of like environment for Ruby. Is that right?
Yeah. I mean, I talked to some other people within this space, and you know, I mentioned Ruby, and they said, "Ruby who? Never heard of her." So that's just kind of consistent with, you know, what I've been hearing. You know, just what you said. How you don't really.
No. Oh, yeah. I mean, it's definitely pretty widespread. Like, I mean, for sure, in my experience, it's just that I have never, like, for my work, I use like Microsoft Stack. So we're doing C#, which is our backend, and that's to say, like, anything that isn't, you know, the content of the web page itself, I'm doing in the backend. Like maybe I'm building, for example, like a list, like some content for a list here. Like I could do that in the back end. Maybe if I don't always know kind of permanently what should belong in this list, maybe in the back end, I could say, okay, we'll build the list of things that I want to show here and send it to this page via a request response. And so at work, I use C# to do that, which is a different, it's just another language. And some people use Ruby to do that. So, but at the end of the day, I would say you still need JavaScript, yeah, HTML and CSS. Those are core. And then Ruby is what you could use to basically build, yeah, like backend code, as well as possibly doing more advanced stuff where a lot of these frameworks, which they call web frameworks, which I mean, we can get into that, you know, it's kind of the benefit of this class. We don't have to go completely linearly. So I'll pull up something about Ruby on Rails. And then I'll also pull up this other one, which I'm more familiar with. So there's this thing called like Flask, which I think is basically similar. But I have used this before. So this is like kind of like the Python way of doing sort of like a complete holistic approach to web, like a web page, like creating like a web application. And it's similar to Ruby in that you pretty much do everything in Python, or in the Ruby on Rails case, which is, yeah, pretty much you'll see a lot of the same vocabulary. I think I saw the word framework pop up. I'm sure if I search it, we'll get it, yeah. So what something like this will let you do is like, you're kind of, I don't want to say you're bypassing, that's a strong word, like you're bypassing the technologies, the core technologies that I mentioned. You're kind of like making it easier on yourself by using this one integrated environment, which like Ruby would provide, or a Python example like Python would provide. So I've used this before, and what you can do is like you basically write Python code to make your HTML files. You can even write Python code that will sort of do a lot of the work that you might instead do in JavaScript, or what you might typically do in JavaScript. So a lot of web applications that are set up like this, you have not very much happening on the user's browser, perhaps, rather than, and instead you just have a bunch of requests. So me as the user, I'll make a bunch of requests which look like this. So here's one, and this request is just getting this HTML file. But like I mentioned before, if I wanted to like, you know, dynamically give you a list of things here, if I wanted to change the content of the list, like this is kind of silly, but like depending on the time of day that you loaded the page, I would need to do that via a request, probably a separate request. So I would load the base sort of structure of my HTML file with like this request still. And then I might make an additional request. And you can see the response here is just literally this HTML page. But an additional request might look like get resources for learning about web. And what I might do in Python or Ruby is like make all of my web pages basically like requests and build them completely dynamically. Like you wouldn't even find necessarily a helpful links.html, but you would find like a file in here that's like maybe like a Python file, and it says like, it has some Python code or Ruby code that says like build helpful links.html. And then it would have code that like tells it like, okay, add this unordered list and add, you know, X many list items, stuff like that. And then send it back to the browser so they can load the page. So that, hopefully, I don't know if that helps you understand kind of like where Ruby, something like Ruby on Rails falls. Another example is Flask, just like a Python one that I've used personally. But that's kind of like where their role is, like where they sit. But they still interact with the core web technologies. That's, you know, just because that is what the browser, like that's what everyone has agreed is like reasonable for, it's like a reasonable standards burden for like everyone who wants to use the web. It's like, yeah, we agree on these three things roughly, among other things like how network requests should be made. And, you know, we kind of stick to those. And then if you want to like interact with them, we can go from there. But
so as I understand it, when we're interacting with a web page, we're interacting with HTML, JavaScript, or CSS, right?
mm-hmm.
But you can use Ruby, Ruby on Rails, Python, or other languages in order to generate JavaScript, CSS, or HTML.
Yeah, that's a really succinct way of putting it. Yeah, absolutely. And that's basically what these things are doing, is they're helping you create templates. They have a lot of stuff like that. Like I was trying to go through and maybe find some really quick, cool, like maybe some examples of using Rails, because again, I've never used it, and it seems pretty interesting. Yeah, your controllers would be like basically the things that are receiving your requests. So if like my page is making requests, the controllers would basically handle those requests and route those page changes that you might want to make within like a web application. I mean, specifically something like this page, I mean, I assume they're probably using Ruby on Rails. You know, the Ruby on Rails site is probably using it. But GitHub is a good example. That's actually just where we were. So apparently GitHub uses Ruby on Rails, which is pretty cool. So you can see this page like does have dynamic content. So it would be useful to be able to organize with like a framework like this, because we have things like telling me when I made a commit or like a change. These files could obviously change if I change them from somewhere else. We would want to dynamically render those. A lot of that dynamic code is just easier to execute on with a framework like this. Yeah, especially if you're trying to build like a true like application versus just like a web page.
When you use these like Rails or Flask type of, I guess, languages, do you run into any issues? Like, are there any disadvantages to using these versus just using the languages that the browsers recognize normally?
Yeah, that's a good question. I would say, I mean, one of the biggest things is like organization and bloat. Bloat's kind of like a common problem that a lot of developers cite when they're either introduced to a pre-existing application or they're kind of brought on to work on one. They just create a lot. I mean, to give you an example with Rails here, to get started, apparently, this is like so what it's showing you, first of all, is like a lot of this setup. This is assuming a lot. I mean, this is assuming, for example, like, this is like Node.js is like, allows you to incorporate a lot of like what are called packages, which would be like written in JavaScript, for example. These things would let you like borrow other people's code that has been packaged, like almost like a product that you can like consume and like use it, like reusing really just basic or helpful or kind of complex code that you wouldn't like rewrite yourself. So it's kind of like a library or package like engine, really. You can also write JavaScript as though we're on the back end. I mean, Node is pretty complicated. I'm not going to confuse too much, but basically Node lets you write JavaScript outside of the browser very effectively. So you can like build like console applications for Windows using Node. So that's kind of cool. You can build, it lets you almost run JavaScript code like anywhere is the sort of like idea there. But you know, this is a requirement for using Rails, likely because it's in a web environment. Obviously Ruby, which is the language, Rails is the framework, and then SQLite is like the database. A lot of times you'll have a database complement to a web app because a database lets you maintain state. You know, if I load your page today, I do a bunch of calculations, let's say, and I save some information. Where do I put that information? Like, where does it go? How do I recall it later on? These are things that like a database solves. You could also put them in like text files. Like I could say, oh, load the page, and if they, you know, if they click this link, open a text file on the server and write like a line that says, page clicked this link, and then save the file. I mean, like, people definitely do that. No problem with doing that if you want to. But, you know, when you're talking about a large scale web application where like GitHub, it's doing millions and millions and millions of like transactions on a regular basis, that's too slow. And it would be ridiculous to manage, right? So that's where a database comes in. And then Yarn, I don't actually know what Yarn is. We can see what it is because I'm kind of interested. Web, I don't know. Web.
Yarn is for making sweaters.
That is true, but okay, it looks like some kind of, okay, Yarn. Some of the names you'll have to forgive, like people in tech. Just kind of stupid.
But I guess my question is, would someone be using Ruby on Rails to do something they wouldn't normally be able to do on JavaScript or any of the?
Oh, you're cutting out a little bit. I'm not sure.
Oh,
there you go. That's better.
All right. So my question was, would someone be using Ruby on Rails to do something they wouldn't normally be able to do in JavaScript or otherwise, or is it more that they already have something written in Ruby, and so they just use this tool to kind of translate it?
Oh, okay. Yeah.
Which of those use cases is like more valid, I guess, or more common?
Yeah, I would say once you start getting larger scale, JavaScript is client-side JavaScript, meaning like JavaScript that runs on my browser gets pretty difficult to maintain. You have to figure out a way to basically manage JavaScript. I mean, and this is really like asking, it's not specifically like a Rails solution or like using another, I guess I want to be clear, like the problem being solved with like a framework like this is not that you're avoiding using like JavaScript. It's more that you're avoiding doing things on the client side exclusively. But furthermore, you are like providing yourself with a huge tool set to quickly build new pages very fast is usually why someone would use a framework like this. And this is very successful for like larger web apps like GitHub, where, I mean, there's tons of pages that they need to spin up here. Frameworks let you do things like establish boilerplate very quickly. Boilerplate would be like, you know, this might not be the best example, but let's say, you know, I go over here, this like view, oh, okay, here's a good, yeah. So this tab, see this tab, like this code tab versus this issues tab versus this pull request tab. See how these two have the same search bar? So like this kind of stuff is what you might consider kind of like a boilerplate. It's a generic search bar. They want this everywhere to look the same. So using something like a web framework lets you say, like, usually in one place, hey, I want this search bar. I want it to always look like this. And this is how I want to reference it in code that I write to build my new pages. That's something that you can do very quickly with a web framework. Now, there are some web frameworks that use JavaScript. An example of this that's very popular would be Angular. Google's Angular is a web framework. React is another web framework. At my work, we use Angular, but we also use Vue.js. Is a popular web framework that is, it's a JavaScript framework. So the code that you're writing is often like valid JavaScript, or well, it's always valid JavaScript because it's written in JavaScript. But some of that JavaScript is running on the client side. Some of that is running sort of like beforehand when you set up all the files to that you want to load for your page. That concept is a little confusing, but it's something that you do in web frameworks to kind of build content. Not on the fly is a bad word. There's a word that's used a lot called like building. Building is like kind of like it's kind of like setup or scaffolding for the ready to consume product. And what that often involves is like running some job or process that automates a bunch of creation of like files that are needed for the code to run successfully. So what I might do on build is like take a lot of JavaScript or Ruby code or Python code that I wrote and sort of turn it into usable code files, which will then be interpreted by something else. So that's kind of a little amorphous description, but I would say, yeah, the biggest achievement of like a web framework is doing things dynamically, creating files for web pages, you know, nearly completely dynamically. Like there are some cases I've even come across using web frameworks where a page like doesn't really exist. Like, I guess it's kind of a weird thing to say, but like a good way to describe it is like no one at GitHub sat down and like wrote some code that said, all right, Page Swanson needs an agent-based models project. So I'm going to write some code that says, create a web page called agent-based models. And on it, it needs to have these things like, it kind of seems intuitive, like when you really think about it, because like you can imagine, obviously that's, it's probably not the case, because that would be kind of ridiculous because there would be millions of these. But this is a good example of like a web framework is really powerful for this because you can write code that writes code, essentially.
Cool, thanks.
Yeah, I don't know, Idris, I don't know if that helped, like, kind of maybe you get a better sense of like what, Ruby on Rails is about or what other web frameworks are about, like when people talk about them. But.
Sorry, can you hear me? Yeah,
Mm-hmm.
that makes sense.
Oh, okay, awesome, cool. Yeah, and if more people are interested in that, I would love to maybe dig into one of these. I guess, want to, in this series, cover a little bit more JavaScript first so that there's like a reference for that to look towards. But, I think we're getting close to the point of like acquiring the tools that we would need to talk about something, at least like a JavaScript framework for sure. Like Vue, we could probably start doing at least some simple stuff. And you can kind of see where this gets a lot of its power. But
real quickly, a quick question is how similar is Ruby compared to these three other languages? Like where does Ruby or Python, because Ruby kind of looks like Python, so I'm wondering where are these derived from, or also like C and these kinds of codes?
Yeah, that's a good note. So where you are looking for is kind of like over here, and then a little bit over here, sort of. But primarily here. This first part is a pretty descriptive. I would say it's the most unifying thing of all of them. If you look at JavaScript, and if we look at Python, pretty sure this is going to work out the way I want. It'll be a little weird, but I'll try to work my way out of that hole if I don't come out with my result. Okay, so also interpreted, right? And as close. Okay, just-in-time compiled is like it's close to interpreted. It's not exactly interpreted, but essentially what this means is like it's evaluated. JavaScript isn't for the most part, but Ruby, it appears, and Python, it appears, are evaluated what's called like kind of like line by line. That is what mainly differentiates them from something like C. C, you'll notice, by the way, all of these except for JavaScript, because JavaScript's weird and it has its own kind of thing going on. That does make it different, though it is, yeah, just in time compiled still. Basically, you'll note that there's underneath these an implementation like engine, and some of them are different. Yeah, I mean, C Python, for Python specifically, it's actually, there's different underlying implementations actually. That's why it says Python interpreters are available for many different operating systems, though this one's the most typical, which means it's C Python, as in like the thing that interprets the Python is written in C. Same goes for Ruby, it looks like. I know a little bit less, or a lot less, about Ruby generally speaking, but yeah, it looks like the implementation language here is also in C. So what that means is like when you write some Python code, when you run it, it's actually working through your Python I don't want to say like in real time, it does make some like, and when I say it, I mean like the engine, or like when the computer is running your Python code, it does make some assumptions and tries to like aggregate statements that you've written, like code statements. But for the most part, it's kind of like going line by line, like, all right, let me try to run this. Let me try to run this. Let me try to run this. C doesn't really do that in terms of like compiling it, which means like basically pulling together all the code that you've written and creating a program. What it does is like it pretty much what is going to run is like we figured that out like once you clicked compile, as in like not at execution time, which means like if I click run, like I already know well before that, like I could figure out what code is going to run pretty much to a T. With Python, you actually don't know necessarily. That sounds pretty complicated if you don't know a lot about like compilers or anything. It is a bit hard to sort of understand how that can work. But for example, with this JavaScript here, I can tell you like basically, well, there's no JavaScript on my page. Let's take a look at like this Ruby page. So it looks like we have some scripts here. So there's some, it looks like they have some guides. So they have some dynamic code here to like set up these different guides and like change some things that happen. So this is the guides menu. So that's probably referring to this. So this code is like controlling what happens when you click this. This code is like kind of like run live, so to speak. Like it's not like some executable, like a Windows executable, if you're familiar with Windows, or like a like I guess like a DMG or something on Mac. Well, that would be like a disk image, but like an application on OS X or something. JavaScript isn't like that. Like in those cases, you click run, and there's no flexibility. Like you can't change the code, and kind of flip it around and just rerun the same block of code, but with a change. In JavaScript, you can kind of do that to a certain extent. And in Python, you certainly can do that kind of thing. Yeah, I don't know if that's super helpful in understanding what I'm trying to get across. But it is something certainly worth like investigating to kind of understand. I mean, this is the part that's really important. I probably should have just like stopped there because it's a little bit hard to explain without some of like the foundations. But yeah, that's how they're different. Is this is interpreted, C is like compiled.
Yeah, I totally understand the difference. There's only so much you can explain in this block of time. I do know about these languages and kind of what they do in general, but I think that was a good, I was pretty good at explaining some of the more intricate parts of it. So thank you.
Yeah, no problem. And actually, one thing I did want to point out are like if you're familiar at all with like running Java on your computer or something, you always have to download like Java. Like you have to download Java to use it. Is kind of one of the caveats of like the way that Java is implemented. It's might see something here about how it has a pretty unique engine underneath it, but maybe you've heard of like the JVM if you do a little bit of like a game, like playing games and stuff, or like if you did like a while ago, maybe it's not so predominant anymore. Like Java specifically, like in the browser, that kind of thing. Like if you ever played like RuneScape or something, it required Java the reason this is because like Java uses its own engine, which I believe, if I remember, was written in C, if I'm not mistaken. So like Java ran on top of this like C engine, or it might have been written in something even lower, like assembly or something. But yeah, you have like many layers, because as you can see here, it looks like people have set up Ruby and Python to run on top of the Java virtual machine. So essentially, people have written, I have heard of Jython now that I think about it. Yeah. So what Jython means is like someone wrote an interpreter using Java, which uses a virtual machine, which is written in something else, which then runs on your computer. So it's like pretty complex levels of abstraction going on to make something like this work, and surprisingly still pretty like efficient and effective at like doing what it needs to do. But the big boast for something like this compared with C is like, to run the Java code, you just need to be able to run this JVM. And the JVM, the Java virtual machine, people would write in with many different implementations. So that's why Java is like became so predominant, because it could like run on any kind of, like all different kinds of machines. Same thing for C, though the reason there is like because it's so, it requires, I guess, like pretty minimal architecture. Like it has minimal architecture requirements. So yeah, you can like run Java also like inside of other things, like if you don't have like hardware access or something. So that's another reason people like Java. And same goes for Python, obviously. Python can sit on top of Java. So, and yeah, I don't know if that makes, if that tracks as well, but hopefully it kind of explains how intricate a lot of this stuff really is, and how we can take advantage of like these abstractions to actually simplify some things. Like if I write in Java, it saves me from having to write like code like, go to this memory address and read like, I don't have to do that kind of thing, because if I have the virtual machine, I can pretend like I'm not on any particular computer. And the implementation of the virtual machine below kind of handles a lot of that stuff for me. So that's kind of the advantage. And same thing goes for Python. That's the advantage there as well.
No. Thank you.
Yeah. And yeah, I don't know if Austin, you're satisfied with that answer as far as like the difference.
Yeah, totally.
Okay, cool. Yeah, I think that was a sidetrack, but like a very important sidetrack, because it's important to remember like what the browser is like responsible for, and this is how like the browser is the one managing all of your JavaScript and all of your HTML and stuff. But you have to remember that the browser is like not a computer. It's actually just an application. So you have this application that's like basically managing the interpretation of all of the code that you wrote.
Would you call it it's not a compiler, right?
No, it's this. That's what brings us back to this, actually. It's a just-in-time, yeah, it has this, or where was it? Where did I go? Oh, I thought I saw it. Yeah, there it is. So it has a JIT. Should come across this word a lot. Yeah, so it like hosts this special JavaScript runner, if you want to call it that. So yeah, nothing on your computer, as far as I'm aware, at least. Like if you don't have a browser, like you don't necessarily have a way to run JavaScript. Yeah, so you would need to download something. I mean, maybe your computer actually probably at this point, like they probably include a just-in-time compiler for JavaScript, but yeah, it definitely used to be like to run JavaScript, you got to have a browser. So there's all kinds of cool stuff with browsers now too. There's this stuff called WebAssembly, which you can get into that's pretty interesting. It's something that is like a new sort of proposal for like, is it like a web standard? It essentially like would run on top of a virtual machine, kind of like Java does, but it's like, you could think of it as like more nitty gritty. It's not concerned really with interacting with something like the DOM. I think I could be wrong about that. So, you know, they're obviously extending it, but to do that, to interact with the DOM, you would like refer to your JavaScript, and then for your WebAssembly, you can do like really, you know, fast stuff like this, like talking about accessing files, the network, and yeah, like clocks, like things that need to be fast and like on time, which JavaScript has traditionally been not very good at, though it's getting better. But yeah, again, we can do all this stuff because everything's like virtual. Like it's not, the browser isn't like a piece of hardware that has like memory that I'm working with. It can run anywhere. Like there's no expectation for the computer like beneath it. You know, you have a lot of flexibility because of that abstraction. I think that's all that we have for our time. You know, I hope that was, hopefully, you know, if anything, I hope it prompts you to maybe like learn a bit more, specifically maybe about, you know, maybe if you were interested in any of these languages that we mentioned, like maybe you heard about it before and you thought like, oh, you know, I want to look more into that, like something like Lisp, or, you know, any of these languages maybe that you just heard mentioned, and you wonder maybe how it compares like Python or like Ruby or JavaScript. I would encourage you to like look into that. And
are there any you would say we should avoid as beginners or anything like that? Just out of curiosity.
Yeah, classically, Perl is really ugly. It's very hard to read. Can give you an example. And by the way, this is just, I'm not going to cover anything super important. So if you need to drop off, if you have other stuff, you know, feel free. I won't be offended or anything. Totally understand that we're at time. But yeah, Perl is pretty difficult to read, as you can maybe kind of see. I don't find it very easy to read. Like, though this does say it's a more complex Perl program, but it's not that complex. It's literally just counting down some seconds. So that's kind of unfortunate that it has to look like that. The other classic one is like PHP. These are traditionally like web stack languages. Like people use them to in the place, like what I was suggesting Python is used for in some cases now, like something like Flask. It's like instead of using Flask, you'd use scripts, like you'd write scripts in like Perl or PHP, and those would sit on your server. And then you'd make a web request and you'd say like, hey, like run this script and then tell me the result or whatever. And then that Perl script might like go to a database, or it might like look up some files or something. Yeah, I mean, they're just kind of, a lot of people criticize these languages. I guess PHP is the one I'm thinking of that's really ugly. This is early PHP. I think it was Perl though. I'm pretty sure it was Perl. People don't. Like, yeah, this isn't so bad. I mean, it's a little legible, a little more legible, but you compare it with something like Python now, that was really made with like readability and understanding in mind. So, yeah, these languages, I mean, there are certainly modern faculties to get going with these. Facebook famously had a crazy initiative that they did to this. Here it is. It's called HHVM, which they paired with this thing called Hack, which basically, like when they made Facebook, they wrote a lot of it in PHP, and then the long and short of it is like they decided PHP sucks. But they were like, well, we don't want to like fix all this PHP. We wrote so much PHP, we're not going to replace it. So what they did was they actually wrote a virtual machine, which is cool. This ties in, which replaces the PHP virtual machine. And they basically like did it such that they were able to create a language on top of it called Hack, which also runs on this virtual machine. So it essentially lets them like run this alongside their PHP without having to replace any of the old PHP, and it lets them like move towards this new ecosystem, but like they don't have to drop any of the old PHP. Like it just keeps going. And they can actually improve the way the PHP runs because they're basically improving the engine underneath it. They're making it faster. So you think of like, I guess the best example of this is if you're familiar with video games, you think of like game engines. That's like basically what they're doing here. So like what, you know, like you think of like Unreal, like Unreal Tournament or something, or like the Quake games. Like there's an engine underneath those games, and you know, as time goes on, they might go and improve the engine. The engine's doing the same thing. It's like helping you shoot a gun or like whatever in the game, or like, you know, like keep score, like or stuff like this. But we're just getting like better at doing it. So they might even use some of their old code. Their old game code. It's not like they rewrite everything from the ground up, you know, like whenever they make a new installation of a game, especially something like Skyrim, something like that, like they might use some of this old code, but the engine underneath is what they're improving. And it allows them, because of that abstraction, to take advantage of new technologies while sort of grandfathering in like maybe some old code. Yeah, this kind of stuff is crazy too. I mean, they were like wrote something to like just literally like ignore the PHP and turn it into other code. That's like a kind of a crazy, which I guess is like what they're doing. But this is a bit different. I mean, this is like basically boiling down the PHP into like simpler instructions. Turning it into PHP is like, it's just very like, it seems like a very daunting task. I guess they really did not want to rewrite some code. Like, I mean, they basically said, we would rather design a way to like transform the code into something else than rewrite it, which is very weird to me, but I guess it was really that bad. Yeah.
That's pretty nuts.
It's really nuts, yeah. I mean, you can read a lot about it, apparently. It looks like there's a pretty good page here. And I'm sure there's maybe a lot of blogs. Because also what is pretty cool is like, I mean, I'm not a Facebook fan necessarily, you know, like, I'm not like, you know, I mean, I think there are a lot of developers and organizations creating a lot of very good code. But I will say that Facebook did, you know, this is open source, as noted here. So, you know, it's not like they just threw this into the void, like this weird kind of quirky PHP engine. Like, it actually helped a lot of people out. because a lot of people were using this old PHP maybe that they didn't want to rewrite. So a lot of people were able to benefit from this in a pretty cool way. And it lets you kind of, improve the way that a language that has some carryover, like that might be old, like, if you think about languages in that way, they're just really these like, they're me attempting to convey some meaning through code or something. But there's nothing saying that you can't like write your own compiler or write your own interpreter for a pre-existing language even, like, so, languages like this have a ton of flexibility just in the way that like spoken languages do. They just have a lot more critical, like sort of simple rules that define them. But yeah, there's a lot of stuff like this, and that where this is done, where you, again, I mean, I think the example I gave for Python, where there's a bunch of different Python implementations like Java, C, etc., is a good example. But yeah. I think that kind of concludes, unless any lingering questions, I'm happy to answer.